Dear all, good morning. My name is Michel Baltas. I'm a research director in the CNRS and work on the Laboratoire de Chimie de Coordination in Toulouse, France. This is a very great honor and pleasure to present the work we have recently published to Royal Society of Mechanochemistry, the new journal that treats the chemical events obtained under mechanochemical conditions. But before entering the topic, I'd like first to address personally my gratitude to Professor Michel Baltas from the École de Mines d'Albi, who initiated me in the field of mechanochemistry in 2012 and with whom I had a collaboration for 10 years until his retirement. The work we published in the Royal Society of Mechanochemistry is a new topic I developed in the Laboratoire de Chimie de Coordination, and it treats on multi-component reactions involving a scaffold that is named lawsone. This work has been developed by Mrs. Christina Koumpoura during her research work. I now let Mrs. Koumpoura and the two most important collaborators here in Toulouse, namely Laure and Christian, to present this part of the work.
Hello, I'm Dr. Christina Koumpoura and I'm very glad sharing with you today our publication. Mechanochemistry has been getting more and more funds lately, and how couldn't it be? It's efficient, econ-compatible and safe to handle. Our work is focused on the study of a classical multi-component reaction called Biginelli. It is a reaction between a urea, a beta-decarbonyl compound, and an aromatic aldehyde, in order to generate the expected heterocyclic DHPM scaffold, which is very important both for synthetical and biological processes. Our discovery concerns the unique outcome of the Biginelli reaction involving lawsone as the active methylene compound. Our study describes the unprecedented high-yield formation of a three-component Biginelli non-cyclized product which was never reported before. And it is not the expected heterocyclic DHPM. This Biginelli linear compound was assumed to be the last intermediate before cyclization in the classical Biginelli reaction. The theoretical research via DFT calculations, directed by Jean-Marc Sotiropoulos, fully supported our experimental results, demonstrating the impossibility for cyclization to DHPM due to a very high final activation step. These results provide a significant understanding of the reaction mechanism, a topic of discussion for numerous generations of chemists.
I'm Dr. Christian Bijani. I work on the NMR facility of the RSC in Toulouse. I provide expert NMR analysis to internal chemist users. I'm the main operator of a Bruker 600 MHz liquid state NMR. And I was very excited to be involved in the NMR characterization of the products obtained by the Biginelli reactions. To achieve this, I used a bunch of 1D and 2D NMR experiments, such as Proton, C13, COSY, HS2C, and HMBC experiments. The complete characterization of this molecule made it possible to attribute the carbon-2 to a phenolic function at 156 ppm. Therefore, this means that there was no cyclization and that it can only be a linear product.
Hi there, I'm glad to be with you today. I am Dr. Laure Vendier. I am the crystallographer who solved and refined the X-ray single crystal structure who is presented in this study. Different assays of solvents with each of the 21 Biginelli linear compounds were undertaken in order to obtain single crystals. After numerous efforts, we were delighted to be able to crystallize one compound bearing an alkene urea function. Crystallization in a solvent mixture of dichloromethane methanol 3,4,1 afforded a single crystal for X-ray diffraction analysis and a very well resolved structure, thus confirming with no doubt the unique outcome of the mechano-mechanical reaction studied.
Okay. Before addressing the future work to be undertaken, I'd like also to thank for this work and for the thesis of Ms. Christina, the Professor Alexander Demling, who is a prominent researcher on multi-component reactions, and for all fruitful discussions we had with him, and for accepting to be in the jury of defense of thesis of Christina's work, and also for the potential future collaboration we will undertake for the work I'll show you now. So 3 points will be addressed for the future work. The first one, the outcome of these multi-component reactions concerning other beta bicarbonyl cyclic compounds, like, for example, syncarpic acid or dimidone. The theoretical aspect of the Biginelli reaction concerning all these cyclic compounds, either studied in solution or under mechanochemical conditions, under solvent-free conditions. And finally, the ways to selectively address the reaction in order to go under mechanochemical conditions to the cyclic Biginelli compound.
For more details, we invite you to check our publication.